Okay, I'm going to save this one for you guys because this one's actually very quick and very easy. So I'm going to save number 7 for you. You should be able to do this in 2 steps and then be done. So try to get this done in 2 steps. Okay. Now, number 8, I said 1 through 17, you won't need a calculator. We're going to need a calculator here. Solve the triangle. When I say solve the triangle, it means find all missing sides and angles, right? So this is a right triangle, so don't start doing law of sines, law of cosines, stuff that we've learned recently. It's a right triangle. Go SOHCAHTOA, go Pythagorean theorem. That's what you're gonna need. And if you would like, I don't label this triangle because it's kind of a pain in the neck to do it in Word. But if you would like, you can label it. So you guys are going to need to find angle B. You're going to need to find, I don't care if you want to call this side A or side B. So angle B, you're going to have to find side B, which is the same thing as saying side AC. And you're going to need to find side A, which is the same thing as saying side CB. Okay. So those are the 3 things you need to find. Use a calculator. Use SOHCAHTOA. Use your 180 triangle rule, and then use your Pythagorean theorem. I'm not going to do this problem. All right. Find the exact value. Find the exact value. Unit circle. Okay. Unit circle. Or if you guys want to like really just throw it back, we can use our special right triangles. Okay. And like I said, I always remember that sine of 30 is 1/2. I just have this ingrained in my brain since since I started learning trig. Sine of 30 is 1/2. So sine of 30 is 1/2, and that means that other side is root 3 because that gives me my 1, 2, and my root 3. All right. And then your 45's really easy, 1, 1, root 2. And if you're like, I don't know about that, you can always like put the radian measures in there as well, all right? So 30 degrees is pi over 6, and 60 degrees is pi over 3. And then your 45s are just your pi over 4s. Okay. That'll help you with reference angles. And then our little trick where all the pi over 3, all the pi over 4s, all the pi over 6s are the same as well. And then just as a last little bit of info here, which quadrants what is negative and positive in. All right, so, so we have secant 150, tangent 4 pi over 3, cosecant of 3 pi over 2. And then the other part, so I'll talk about this 3 pi over 2 thing. Okay. Remember, on your unit circle, we have these quadrant angles, 0, 2 pi, or 0, 360. All right, this point is the point 1, 0. It's on the x-axis. Okay, this is 90 degrees, or pi over 2, and this is the point 0, 1, right on the positive y-axis. Okay, this is going to be pi, or 180. This is going to be the point negative 1, 0. And then down here is going to be 270, or 3 pi over 2, and that's going to be the point 0, negative 1. All right, and then as a reminder, 0 over a number is equal to 0. A number over 0 is equal to undefined. All right, so that's going to help you with D. That's going to help you with some of the other quadrantal angles. So I'm not going to do these 4. Use your special right triangles. Use your cute little nuggets of information that we've learned. I will for sure do E, sum or difference identity. You really have one just like this on your exam. It literally looks like this. I literally say use a sum or difference identity, so make sure you know them. All right, and I'm just going to go through this one more time. If you have cosine of A plus or minus B, so if we're adding or if we're subtracting, this is what the rule looks like. Cosine of A, cosines together, and then it's opposite sign of what you're doing. So if you're adding, you're going to subtract in the middle. If you're subtracting, you're going to add in the middle. And then your signs go together. And then your sine, we're going to flip-flop the trig functions. But we get to keep the signage. So with whatever if you're adding inside, then you're going to add in the problem. So we have sine of B, cosine of A. we flip-flop. You're probably not going to need tangent, and if you're going to need tangent, it's going to be, I set it up so you can do sine over cosine, so don't worry about memorizing the tangent one. Okay. Cosine of 255. All right, if it has a 5 in it, that probably means there's a 45 involved. And if you take 255, if you take 45 away from 255, you're going to get 210. So 255 breaks down as 210 and 45. So I could really write this as 210 plus 45. This is probably not the only way to write this, but this is the way that I thought of first. So you don't have to come up with all these different ways to get to 255. Just come up with the ones that you see first. And I always, if there's a 5 there, I always see the 5 and think 45. All right, so I'm going to follow my pattern, and then I'm going to leave that rest of that for you to solve and finish out. So this is just going to look like cosine of 210, cosine 45, minus opposite sign of what we're doing, sine of 210, sine of 45. All right. I'll let you guys finish this out, but that is how we do it. These are your 2 sum or difference formulas that you're really going to need to know, and go from there. Okay. For y equals 10, negative 10 tangent 3x plus 2 pi over 3 minus 3 minus 5. Okay, list the following. Phase shift, I'm going to change this. Like I said, your book likes to use the word phase shift. I like to use horizontal shift, so I'll make sure it will reflect that on your exam. Now remember, for tangent, there is no amplitude. I will not ask you to graph a tangent function. I will just ask you to tell me stuff about it. So there is no amplitude on tangent. Okay? Even though it does have that negative 10, it gets you get really excited about it. Don't do it. All right. Now, this other stuff, what I really want to do is make sure that we factor out anything in front of the variable. So whether that's an x or a theta or whatever it may be, we want to take out this 3. Okay, so if I take out this 3, if I divide this by 3, I'll get x. And if I divide 2 pi over 3, I'm going to get 2 pi over 9. Now, if you're not sure if that worked out right, you can multiply back through. You get 6 pi over 9, which is the same thing as 2 pi over 3. Now, this would be a nightmare to graph, so thank God we're not graphing it. Okay, so my horizontal shift is just the opposite sign of what's inside. So it's going to be negative 2 pi over 9. It's very exciting. My vertical shift is negative 5. And then my period, tangent, and cotangent, but we don't mess with those guys. The period is going to be pi over b, and that's because of all those asymptotes. For sine and cosine, the period is 2 pi over b. So make sure you know that difference. This is a mistake a lot of people make. So the b is this number 3 in front of those parentheses. So my period here is just going to be pi over 3, not 2 pi over 3, just pi over 3. So a couple of things here. Factoring out the 3, it's no amplitude because it's a tangent, and then we have a period, just remembering period is pi over b for the tangent function. Okay, and I'm going to graph this one with you guys. I did not ever assess you guys in graphing. That was when everything started to happen here. So we're going to go through it, and if you want a couple more practicing with graphing, just go over what I gave you, go over the review, and then even go through that mock test I gave you if you want some more practice. All right, so graph this function for x between 0 and 2 pi, mark all quarter marks. We've talked about this. So before I graph it, what I want to do is I want to factor out this 2. Okay, so I'll get x plus pi over 4 in parentheses minus 3. All right. There's everything you could possibly have going on here is going on here. All right, amplitude. Amplitude is the absolute value of the number in front. It is positive 2 because amplitude is a distance. We're just going to flip it. My period is going to be 2 pi over b. Okay, my b is that 2 that I factored out. So my period is going to be 4. And then remember our little trick. we divide the period by 4, and that's what we count by. So that's exciting. My phase shift, like I said, I'm going to change this so it says horizontal shift. I will change that, promise. My horizontal shift is going to be negative pi over 4. And that's where I start. My vertical shift is minus 3. All right, so how I like to graph these functions is I like to graph that big chunk first, and then I'll worry about the vertical shift, all right? So let's graph the big chunk, and then let's talk about the vertical shift, and that means we just have to shift everything down, so it won't be a big deal. All right, so let's mark all these points. Pi over 4, 1 pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4, 4 pi over 4 is pi. We'll go negative for a couple. Okay, pi, and we'll go one more. All right, and I'm going to count by ones here. All right. So we are going to start at negative pi over 4. All right. It's a sine function, so it starts at 0, 0. But since I'm shifting it to negative pi over 4, I'm going to start here. Usually sine starts 0, 0, goes up, goes down. Cosine starts up high. So I'm going to start here. And instead of starting here, I'm going to start at negative pi over 4. So we're going to start here. Okay. And then my amplitude is 2. So typically I would go up to 2. But because I'm flipping it, I'm going to go down to negative 2. All right. And we're going to follow our pattern. Okay. And I know I have to do the shift, the vertical shift, but I will do that in a second. Okay, but just follow our pattern as we go. All right, that looks great. All right, so this is what this graph looks like here, all right, without the vertical shift. My vertical shift tells me shift everything down 3, all right? I think I'm just going to fit this. All right, so shift down. Okay, so negative 2 goes to negative 5, 0 goes to negative 3, 2 goes to negative 1. So best you can. It's got to look all right. Here we go. I don't have a different color on me. Otherwise, I would do this in a different color. So I apologize. All right, so this bottom one is our graph. If you want more practice with this, look at all the stuff that I gave you. Look at the review that for this quote-unquote exam. Look at the actual exam I did for practice on this.